Okay, so in today's video we're going to have a look at using trigonometry to work out the missing side lengths on right-angled triangles. Now this part of trigonometry we're going to look at is purely for right-angled triangles, but we're going to have a look at the steps that we need to take obviously when we're starting with this topic. So grab a piece of paper, grab a pen, make some notes, and we're going to get started. Now if I just draw a little right-angled triangle here, the first thing that we need to be aware of is how to label the triangle. Now when I'm looking at this triangle here, and I'm just going to put a random angle in there, and let's say 40 degrees in this angle. Now if this is the angle in the question that we're looking at, we label the sides according to that angle. Now one side that never changes is the hypotenuse, and you can find the hypotenuse by drawing a little arrow out of the right angle, and that always works, and it's something that hopefully you've seen. Obviously we're looking at my Pythagoras video as well. So if we label that side there, that side here is called the hypotenuse. There you go, the hypotenuse. Now the other sides we're going to label in relation to the angle, like I said. So the first one that I always label is the one that's opposite the angle. So if I draw an arrow out of the angle that I'm using, that gives me the opposite side right there. So that one's called the opposite side. There we go, and that's the opposite. The one that's left over is called the adjacent. So the one that we've got left over is called the adjacent. There we go. And that is how we label our triangle, and that's always step one when we're looking at using SOHCAHTOA to find missing side lengths. Now, obviously this question might have been different. The one thing that could have changed is the angle could have been up in the top right hand corner instead. So if that was the case, and if the angle was instead up here, and let's say instead that angle's there, and let's just make up a random angle, let's say it's 34 degrees, that wouldn't only change the opposite and the adjacent, so they would have to be the other way round, because now, pointing out of the angle, that is no longer the adjacent, it's now the opposite. So if the angle was there, all we'd have to do is label it ever so slightly differently. This would now be my opposite. There we go, and this would be my adjacent. Okay, so in terms of labelling the triangle, that's it. There's only one other thing that you need to use, and I am going to be using formula triangles in this video. Again, it's not the only way of using SOHCAHTOA, but it's just a nice, memorable way that makes it nice and easy for you. So I know everybody doesn't like formula triangles, but for the purpose of this video, I am going to be using formula triangles for this. So if we get rid of this, the formula triangles that we need to remember are, and let's make that a little bit bigger. There we go. We've got 3 to remember. And if we draw our little triangles in, we have SOH, CAH, and TOA. Okay, so we just have to remember SOHCAHTOA, and looking at the way that it's spelt there, it's spelt in a kind of odd way, because as we read it, it goes SOH in this direction, CAH in this sort of direction, and TOA in this sort of direction, spelt in little triangles, okay? But all we actually have to remember is SOHCAHTOA and how to label the triangles, and we're going to have a look at how we actually use this now on a question. So let's have a look at one of those. Okay, so this question says work out the length of BC and give your answer correct to 3 significant figures. Now looking at the question, BC is this side here that we're trying to work out. So first things first, I'm just going to label the triangle. So opposite the angle is my opposite, so we're trying to work out the opposite. I'm going to shorten that to just OPP for op, and then I'm just going to label this other length here. Now we've been given one of the lengths, and that's 8.7, so I'm going to label that one. Now it's not the hypotenuse is here. If we label that with a HYP, opposite the right angle, so that one there is my adjacent, which again I'm going to abbreviate just to ADJ. Now we only actually need 2 of these letters now, okay, and the one letter that we do need is the one with the side we've been given, so we need the adjacent, and we're looking for the opposite, so we need to use the opposite as well. So actually I don't need to use any formula with the hypotenuse in for the purpose of this question. Now the next thing I need to do is decide which formula I'm going to use. So I'm going to write down my 3 formula triangles, SOH, CAH, TOA. And all I'm going to do is I'm going to pick the formula triangle that has the A for the adjacent and the O for the opposite in. And if you have a look at those 3 formula triangles, that is my tan triangle, TOA. Okay, so now we just have to think how we need to use it. Now if you've used formula triangles before, you'll know I just cover up or cross out the one that I'm looking for. And in this case, we're looking for the opposite. So if we're looking for the opposite, we cross out the O. And that means I've got t and a next to each other, and that means that I have to do a multiplication. Okay, so if they're next to each other, we do a multiply. So what I need to do is I need to do t times a. Now, we just need to know what t is. Now, t stands for tan. Remember, S, C and t stand for sin, cos and tan, which are basically just buttons on your calculator, but I need to figure out what goes with tan. Now, whatever angle I've got in the question, that's what goes with tan, and I'll explain why. Okay, so when I put this into my calculator, I'm going to put in tan 36, and 36 needs to go in a little bracket, and you need to close the bracket there. Now when I type that into the calculator, and if you're following along with me, I'm just going to type that in now, tan 36, you get a decimal on your calculator, and that decimal comes out as 0.7265. And if I just write that down, 0.7265, there's a few more decimals there, but it's just important to understand what that decimal actually means. Now all that means is that's the relationship between these two things in our formula triangle, and that was the O on the top and the A on the bottom. So tan 36 tells us the relationship between the opposite and the adjacent side, and 0.7265 as a percentage is around between 72 and 73%. And all that means is that for this particular angle, the one side is going to be between 72 and 73% of the other, specifically 72.65 and a bit more percent, but one is going to be that much smaller than the other. Okay, and doing this calculation is going to basically work that out for us. And we can think about it logically, but we already know we're going to do a times, so we've got tan 36 on the calculator, and we're going to multiply that by the adjacent side, which is 8.7. So tan 36 times 8.7 is going to give us our answer. And thinking about this logically, if you multiply 8.7 by 0.7265, that number is going to get smaller. And if we do it on our calculator, let's go for it, tan 36 times 8.7, we get the answer here, and let's write it down, 6.32091994. There we go. And we are going to round this in a second as well because it wants it to three significant figures, but there we go, that gives us our answer, and logically you can see that that's going to make sense. Now it's kind of hard to tell with the opposite and the adjacent which one's the bigger or the smaller side, but when it comes to looking at the hypotenuse, you can normally tell that it's going to make sense because obviously the hypotenuse has to be the longest side, and we will have a look at that on the next question. But for this question here, three significant figures, I'm going to chop that after the third significant figure there, which is the 2, and I get a final answer of 6.32 centimetres. And there's the final answer for this question. So just very quickly, thinking about what we actually did there. Step 1 was to label the sides. We only labelled the 2 that we needed, one that was given to us and one that we were looking for. Then we picked out of our 3 formula triangles there, which you do have to know off by heart, which one had those 2 letters in. So it was the O and the A, which had tan in, which was in the tan triangle. So then we were able to figure out which one we were looking for. We were looking for the opposite, so we crossed that off, and it showed us here that we had to do a times. So when they're next to each other, we do a times. And then we just plug that into the calculator. So tan 36 times the adjacent, which was 8.7. And it's very important that you do always put the angle with the tan, whether we're using sin, cos or tan, because that's what tells you the relationship between those two sides with that particular angle. And there we go, the rest was just plugging it in and writing our answer. So we're going to have a look at another one. We're going to follow all these steps, so hopefully you've made some good notes on that, because all we're going to do is do exactly the same thing and just follow those few steps. Okay, so here's the next one. Okay, so this one says work out the length of x and give your answer correct to 3 significant figures. Now again, step 1, let's label the triangle. Opposite the angle is our opposite, so we've got the opposite in this one. And there's that one. And the other one we need to label is the one we're looking for, which hopefully you can see is the hypotenuse there, it's opposite the right angle. So in this question, the adjacent, which is down here, we don't need. Okay, so we're not going to be using the adjacent. So again, writing out your formula triangles, SOHCAHTOA. And I just need to figure out which formula triangle there has the O and the H in. O for the opposite, H for the hypotenuse, because they're the 2 we need. And hopefully you can see that is the sine triangle there. Now in this case we are looking for the H, so we're going to be crossing off the H in our formula triangle, and that means we've got O over S, and when it's O over S it's O divided by S. So to work out the hypotenuse we do the opposite side and we divide it by sine, and whatever sine is in this case. Now the opposite side is over here, it's 20, so we're going to do 20, and we're just going to divide that by sine, and if you remember, what goes with sine? This angle here. So sine 35 in the bracket. And again, you can type sine 35 in on your calculator. It gives you the answer 0.5735, which is, again, that is the relationship between the opposite and the hypotenuse when the angle is 35, okay? So 0.57 is around 57%. And then when we type that in, so let's type that in, 20 divided by sine 35, and that equals 34.86, with a few more decimals, but it wants me to round it to 3 significant figures, so I'm going to stop there. And if we round this to 3 significant figures, chop it after the 8, and we get 34.9. There we go, and again that is centimetres. And there we go, that's using SOHCAHTOA. Now obviously there's 2 different scenarios there. We looked at one where there was a multiplication and one in this case where there was a divide. But they're all there within the triangles for you. All you have to do is label the sides, pick the triangle, and then just follow the steps within the formula triangle. Okay, so we've got 34.9 for this one. You just need to make sure on the divide that you don't accidentally do these the other way round. It is 20 divided by sine 35, the opposite divided by the sine, not the other way round. So do be very careful that you don't get them the wrong way when you do that. Okay, so you need to just follow those steps, label the sides. Step number 1, write down your formula triangles and pick the one you need. And then step number 3, plug your numbers in. Okay, and just follow the formula triangle. Make sure you cross off the one that you're looking for, and then you can just find that missing piece of the triangle. Okay, so here's some for you to have a go at. Okay, so there's 2 questions there. So again, label the sides, pick your formula triangle, plug in your values, make sure you're careful whether you're doing a times or divide, and then write down your answer. Okay, so pause the video there, have a go, and we'll go over the answers in a sec. Okay, so working out the length of x for this one. So x is opposite the 60, so that's the opposite, and 32 is the hypotenuse. So we're using the opposite in the hypotenuse. So we're going to be using SOH, we're going to be using our sine formula. Now again, with this one, we're trying to work out the opposite, so we cross off the opposite, which means we're doing a times. So we're going to do sine times the hypotenuse. So with the case of an angle of 60, we do sine 60. So sine 60, that's another 60, that's a 6, sine 60, there we go. And we're going to multiply that by the hypotenuse, which is 32. And sine 60 times 32 on the calculator, sine 60 multiplied by 32 gives us the answer 27.712. So 27.712. There are more decimals, but again, it asks for 3 significant figures. I don't know where the word figures has gone, but rounding that then, we get 27.7 centimetres, and there is our final answer. On to the next one, working out the length of AC. Well, AC is the hypotenuse, and BC there, the length that we've been given is the adjacent, okay, opposite the 35 there, we don't need, so we don't need the opposite. So writing down our formula triangle, we should see that that is the one with C, A and H in. Okay, looking at A and H. And this time we are trying to find the hypotenuse. So if I cross off the H, we have A divided by C. Okay, we've got H and A, and we're doing A divided by cos. Okay, so A is down here 20, so we have 20. And we're going to divide that by cos, and the angle we're using is 35. So cos 35, and if we type that in on the calculator, 20 divided by cos 35, we get the answer 24.415. So that's 24.415, and again it only wants it to 3 significant figures, so I don't need to write them all down, but if I chop that again after the 4, it gets us a final answer of 24.4, and that is, again, centimetres, and there's our final answer, 24.4. Okay, right, let's have a look at something slightly different. Okay, so this says work out the length of CD and give your answer correct to 3 significant figures. Now we've got 2 right angled triangles put together here. You can see that from the right angles in them. So in fact we can't actually work out the length CD just looking at the triangle on the right, and it's often the case when we've got 2 triangles put together that we need to use the other triangle first to find one of those lengths. And if you have a look at this triangle on the left here, ABD, we have got two of the lengths there. And we don't actually have to even use SOHCAHTOA to work out this missing length here, because we can use Pythagoras. So obviously I went over Pythagoras in the previous video, but in order to work this one out, it's one of the shorter sides, so we can do 16 squared, subtract 12 squared, and then we'll square root our answer. So 16 squared, take away 12 squared, leaves us with 112. And then we want to square root 112, and that gives us 10.583. 583, and again there are some more decimals there, but it's 0.0524, and you can write it all down if you want, but if it wants it to 3 significant figures, I've kept it to 5 there, and that should be plenty. So let's label that on. So 10.583. Now we can go about using SOHCAHTOA. So that 10.583 is opposite the 40, so that's my opposite side on this right hand triangle. And then we're also trying to find the length of CD, which is this one here, which is opposite the right angle, so that there is the hypotenuse. So now we can actually go about using our formula triangles. So O and H is in our sine triangle, O and H. And if I want to find out the length of the hypotenuse, I can cross out the H, and there we go, we're doing a divide. So it's O over S, which is 10.583 divided by sine of whatever angle we're using, which in this case is 40. So 10.583 divided by 40, let's type that in. Answer divided by sine 40, and we get an answer of 16.46. So let's write that down. Let's bring it up here. We get 16.46423 and some more decimals there. But again, we only need it to 3 significant figures. So finishing this off, I can round that. 3 significant figures chops it after the 4. So we get a final answer of 16 points, and the 4 rounds up to a 5. 16.5 centimetres. And there we go. Okay, so a slightly different question there. We have to use a bit of Pythagoras as well, but you just know obviously if there's no angles involved with a right angle triangle, you can use Pythagoras, but if there is an angle involved, that's when we start to use SOHCAHTOA. So let's have a look at another question. Okay, so this question here says work out the length of AC, and AC is the full length all the way along the bottom of this triangle. So first of all, let's have a look at what we can work out, because we certainly can't work that out in one go. Now looking at the triangle on the left, we can definitely use SOHCAHTOA to work out either the length of AD or the length of BD. Okay, so it doesn't really matter which one we go for. We could work out AD straight away, but looking at that triangle on the right, we're going to need to know what this length is here in order to work out the length of DC. So if I use SOHCAHTOA to work that one out, that's opposite the 65, so that would be my opposite, and 7 would be my hypotenuse. So O and H is in my sine triangle, so SOH, and we are trying to work out the opposite. So cross off the O, and we're going to multiply. So we're going to do 7, which is the hypotenuse, and we're going to times it by sine 65. Okay, you can always write it around the other way like it is on the triangle, but it doesn't matter as long as we close the bracket there. So 7 times sine 65 equals 6.34. I'll leave it to a few more decimal places so I don't get any rounding errors here. So it's 415 after that as well. So 6.34415, and let's label that on the diagram. So 6.34415. Perfect. Now what can we do? Now we can either work out the length of DC, because that right triangle there now, we've got 2 of the lengths. We've got 6.34415 and we've got 12. So we can use Pythagoras to work that one out. Or we could use Pythagoras again to work out the length of AD. Now it doesn't matter whichever one you prefer, but we're going to need to use Pythagoras for this one on the right hand side. So if we work this one out first, we can do Pythagoras to work that out. So it's one of the shorter sides, so we'll do 12 squared, take away 6.34415 squared, so 12 squared, take away 6.34415 squared, and we're going to square root the answer. So let's type that in, 12 squared, take away 6.34415 squared, and that gets us 103.75. So we'll do the square root of 103.75. There are some more decimals there. So square root the answer, and we get for the length of that 10.1858. Again, there are more decimals, but it wants it to 3 significant figures, so I'll leave it just to that at the moment. So let's write that down here. 10.1858. There we go. Now we've got that one. Let's get rid of that drawing there. Okay, there we go. And that's the length of D to C. And that's part of that done. Now it's completely up to you on this left-hand triangle because we want to find the length of A to D now. And you could either use Pythagoras or we could use SOHCAHTOA again. Now as we're looking at SOHCAHTOA, I'm going to decide to use that. But we could just do Pythagoras doing the 7 squared, take away the 6.344 squared, and square rooting our answer. But I think this is quite important because we've already labelled that at once. Now if I want to now use SOHCAHTOA again, I have to completely relabel the triangle because now we're looking at finding this side, which is the adjacent. So we could either use the hypotenuse or the opposite because we have them both, but I'm just going to decide to use the hypotenuse here. Okay, so it doesn't really matter which one we go for, but you have to make sure that you use the one that you are labelling. So A and H is in my CAH triangle, and we're trying to find the adjacent. So I'm going to cross that off and we're going to do a times. So I'm going to do 7, the hypotenuse, I'm going to times it by cos 65. There we go. And 7 times cos 65 is 2.958. So 2.958. Let's keep it to the same amount of decimals as we did before. There's a 3 after that. There we go. And that is the length down there. So let's get rid of that A and let's label that. So 2.9583. There we go. So we have our two numbers now to get the full lengths. So we can write these down. Let's get rid of this working out. So we've got 2.9583. And we're going to add that to 10.1858. There we go. And if we add them together, let's type it in. 2.9583 add 10.1858, and we get 13.1441. And now I can round it as the question said, giving it to 3 significant figures, and that's after the 1. So our answer is 13.1. Check the units, centimetres. And there's our final answer for that question. So a little bit more complicated there because we had a few more steps. We had some Pythagoras. We chose to use SOHCAHTOA twice. So you could have used SOHCAHTOA in that last step. It just depends on which one you sort of find a little bit quicker to use. Obviously, if you already know Pythagoras, you'd probably opt to use Pythagoras there. But obviously, as you're now looking at SOHCAHTOA, we should have a look at how we use that and how we approach it. Because it might have been that we had to use SOHCAHTOA on the second chance there. Okay, but here's a question for you to have a go at before we finish. Okay, so here's the last question. So pause the video there, have a go, see what you get, and we'll go over the answers in a sec. Okay, so calculate the length of x and give your answer to 3 significant figures. Now for this first step here, look, we're going to have to find out this length. And in order to find that out, we're going to have to use Pythagoras. On this left-hand triangle, we've not got any angles, and on the right-hand triangle, we've not got any of the lengths at all. So we're not going to be able to use that triangle on the right just yet. So to work out the length of x here, we use Pythagoras. We've got the hypotenuse, so we've got to do 20 squared, the longest side, take away 16 squared, and square root our answer. So 20 squared, take away 16 squared is 144. There we go. And that's quite a nice one because the square root of 144 is a whole number. It's 12, so 12 centimetres. So we can get rid of that x and we can label that 12 centimetres. There we go. Now we can use that to work out the next part. So looking at the right hand triangle here, 12 centimetres is the opposite the angle of 25, and x there is our hypotenuse. So we've got O and H again. So SOH, and we are trying to find, let's have a look, the hypotenuse there. So cross that off and we're going to do a divide. So that's O over S. O is 12. Sine of the angle, so sine 25, the angle that we're looking at, and type that into the calculator. So 12 divided by sine 25 equals 28.394. Let's write that down. We get 28.394. It wants our answer to 3 significant figures, so that's after the 3. So our final answer here is 28.4. when it rounds up, and that is in centimetres again, so 28.4 centimetres. And that is the final answer and the final question that we're going to be looking at for side lengths. In the next video we're going to be having a look at finding angles, although to be honest it's only an extra little additional step on top of finding side lengths. It's not actually that much harder, there's just an extra button on the calculator to press, and that is pretty much it. Okay, but get yourself familiarised with labelling the triangle. Make sure you're happy with always putting the angle in with sin, cos or tan. Make sure you're happy on when to decide whether to times or divide, and obviously just make sure that you're happy using your calculator for these. But if that was helpful, if it was useful, please like, please comment, please subscribe, and I'll see you for the next one.